Well, it's 1 minute after 3. So let's get started. Welcome to this tutorial on ARK identifiers, if you're here for something else, you probably want to find that other room. We'll be running it for an hour with some time for breaks and questions. I haven't timed this officially, so I may have to speed up at different points. I think you all have stickers, really important, and you probably all have Wi-Fi, which is useful to have and to test things out. My name is John Kunze, and I developed this course with Donnie Winston, who couldn't be with us today, unless he's joined online, I'm not sure. So it's really nice to have a small group. I think we don't have enough time for round the room introductions, so I encourage you to look at find the notes for this session and to inscribe your name there. I'll tell you, in my case, I'm a computer scientist who's been working for the past 25 years with libraries, museums, and archives on information standards and persistent identifiers and metadata standards. So the goals of this session are to know when to use ARK identifiers, learn a little bit about the archival resource key anatomy, and to be able to create and resolve ARKs. So why should we care about ARKs? The average lifetime of a URL was once said to be 100 days. At the end of its life, a URL link breaks, usually giving you the dreaded 404 not found error that most of us have seen. So irritating as that is, it's a minor disaster for memory organizations. So ARKs can serve as robust links, also historically known as persistent identifiers or PIDs. The ARK scheme is one of 5 so-called persistent identifier schemes, but there's been so much nonsense written about PIDs that we prefer the term persistable. Some of this is described in a Twitter thread that you can find by searching for 10 persistent myths about persistent identifiers, or you can use the link here on the screen. And of course, there's an example ARK there. So every URL is potentially persistent, but strangely, some people think a URL becomes a PID when it acquires some superficial syntax differences, such as putting ARK and a colon inside there, or putting a doi.org as a domain name. Syntax is no guarantee. It's never more than a suggestion that you might find this link to be more stable than 99.99% of URLs that are produced without any thought for their preservation. So-called persistent identifiers of all schemes break regularly by the hundreds of thousands, which is a normal part of providing a preservation service. Committed service providers will sometimes even repair those broken links. So syntax doesn't make it persistent, just the possibility of being persistable. Anyway, this nonsense was in full bloom in the late 1990s, but nonetheless, it became the basis of 4 proposed PID schemes. So that's why in 2001, the archival resource key or ARK identifier scheme was introduced. So here's what an ARK looks like. At first glance, it's a URL that carries this internal label. To the right of that is the 5-digit name assigning authority number, or NAN. It identifies the organization that created the ARK. Further right is the part after that names the actual thing that the ARK is assigned to. To the left is the host name makes the ARK actionable, or something you can click on. It's also known as the resolver. ARKs are unusual in persistent identifiers schemes because they allow organizations to run their own resolvers. The part starting with the ARK colon is it's the core globally unique identity. It doesn't depend on the domain name, doesn't depend on the server being there or on the future existence of the World Wide Web. So finally, why is the ARK resolver called N2T? Why doesn't the ARK resolver contain the letters ARK or like arkresolver.net? The ARK design wanted to break out of the silos and the walled gardens surrounding resolvers for other identifier schemes, which are meant to exclude. So what got built was this name to thing resolver. So N2T stands for name to thing. The short name helps for short citations, and it also happens to resolve hundreds of different identifier schemes in their compact form. So here's the homepage of the global ARK resolver, the name to thing resolver. The name is short, it's mostly opaque, and N2T is opaque until you learn it, and then you know something about it. So it's patterned after some of the mapping operations proposed in 1997 for the URN, which is the reason we say URI today, because URL became partly the URN. And then anyway, there was a set of mapping operations, and this sounds like one of them. Once again, it may seem unusual, but the ARK brand is not present in the resolver name. We see resolution to be a trivial table lookup operation, and it makes no sense to create different database systems based on which part of the alphabet the primary key begins with. It just doesn't make sense. So another big benefit of N2T is that it resolves over 900 different compact identifier schemes. So if you forget where the resolver is for ISBNs or PubMed IDs or Protein Data Bank or GenBank or DOIs or handles or ARKs, you just prepend N2T.net and you can get to N2T will remember for you. And then you also get to display just the short compact form and hyperlink it to the longer actionable form. So I invite you to visit N2T right now and check it out. So ARK organizations include a wide variety of memory organizations, nonprofits, for-profits, government agencies. A few of them are listed on this slide. We've seen accelerating adoption in South America, Africa, and India. You can see an ARK in action, for example, from the Louvre Museum in the lower right-hand corner. So what are people using ARKs for? Here's a list of examples. In descending order, according to the number of ARKs assigned, I'll mention just a few. The heaviest user by far is the largest genealogical research organization called Family Search International. Next is the archive of all the source files for mainstream published content. It's Portico. Technically, they have over 40 billion ARKs, but apparently only about 100 million are interesting to outsiders, or so they say. A lot of this is anecdotal, right? Because we're decentralized. So we don't have firm numbers, we just have stories that we've been told. The Internet Archive has been assigning ARKs to scanned book texts since 2008. The Smithsonian is rapidly expanding their use of ARKs. They have about 15 million, I believe, with a target of 150 million. The French National Library was an early adopter, and here's a nice image of depicting the biblical ARK, which is a detail on one of their medieval manuscripts. Of course, there are ARKs for fine art. There are also an important category is abstractions and concepts used in the semantic web. So things like diseases, vocabulary terms, time periods, these all get ARKs. We'll take a brief look today into about 4 different ARK implementations. And starting with the first one as a brief case study for the Internet Archive. Note their reserved NAN, name assigning authority number, is 13960. If you get to be a geek, you can sort of memorize a few of these. This is an example of a library standard, the MARC standard. for our metadata, which is widely hated and loved depending on who you talk to. Dublin Core was a reaction to it. This instead of, the Dublin Core was supposed to be a standard that didn't register on a bathroom scale compared to the foot thick mark standard or set of mark standards. So on the right is this metadata record where you can see the ARK in the red rectangle. And then you can see its NaN. You can also see how different it is from the identifier above it, which is a lot less opaque, which is helpful for the backroom people. You can also see the URN identifiers that are above that. So a couple of things. There in the real world, there are multiple identifiers. It's messy, but it's good practice is to keep your identifiers around because provenance and tracing and tracing back, it's good to keep that. That's the end of the first case study. Any questions? Okay. So a little brief history of the persistable. Yeah.
Question.
Yeah.
Can I use the,
Oh, right.
From Diana, who is responsible for maintaining the validity of the identifier, for instance. She gives some examples of Zenodo links that are broken.
Right. Yeah. So who is responsible for the validity of the identifier? Well, it's a distributed, decentralized system. In fact, responsibility for preservation and persistence of all persistent identifier schemes is heavily depends on the last 5 yards. It's the end provider. You can have your expensive DOIs and screw everything up by removing things and failing to update tables. So there's a combination. It's a partnership between the end provider and the resolver updating facility, their uptime. So all these systems have to be working for the whole thing to work. So any other questions from out there? Okay. So again, we're talking about we'll call all these schemes persistable. The short history, Pearls were an original early one from the library community, actually. Basically, their motto was they fully embraced Pearls. They fully embraced the URL. Said Pearls, URLs are good. Let's just go that route and redirect them, keep them up to date by redirecting them. URNs, DOIs, and handles got confused for a while. They sort of said, well, oh gosh, URLs are terrible. Look, they break all the time. The URL, therefore, is bad. And then they decided that, they kind of decided that was wrong because after all, we had to do our business in URL land, and they ended up publishing everything under URLs. And so they re-embraced the URL, but basically said that, our domains are trustworthy. And the inventor of the web, Tim Berners-Lee, said, well, cool, URIs don't break. And what he meant is he wasn't that interested in persistent identifier schemes. He said, just manage them well. And what the ARK scheme says is, let's be real here. 99% of the URLs in the world aren't meant to persist. Nobody, and the people who provide them don't have the ability or capacity to maintain them. So let's distinguish ours. Let's embrace the URL, add a label to say, hey, there's a hope that this might do something interesting. And let's make sure that we embed the globally unique identity without using the domain name. So to the right, it's the beginning of the URL path. That's the basic idea. So here's the grumpy old man view of identifier schemes. It's like, why bother? If you look at the first 3 lines here, you go, wow, no persistent identifier scheme does anything important, things that I really want done. They don't help me at all with the major and minor causes of preservation failure. There are some edge cases where some bad practices that could be avoided. It's kind of like make sure your windshield wipers are working, and that'll reduce traffic accidents by 0.1% or something. So there are a couple of things that you could do. So consider not using PID schemes. That's a valid approach. So let's make sure that people understand what web redirection is or web indirection is. So the normal web access simplified view is, user clicks on something, the browser goes to a web server, it returns a page, displays it, done. That's the sort of direct access. So indirect access is where the first server you ask doesn't know the answer, doesn't have the resource, but says, I think this other server has it. So it sends, unbeknownst to the user, the request is forwarded to a separate server. So that's web redirection, that's web indirection. And often there's a chain of redirects that takes place, maybe 10, 14 redirects. All of this is so fast, the user is completely unaware of this. Or usually unaware of this. So it's basically forwarding to another address. So here's another view of PID schemes, a more optimistic view. If you buy into the notion that PIDs can actually provide value, here's some detail. By an amazing coincidence, this table is quite flattering to ARKs. I don't know how that happened. The bottom line is that it's about costs. No user pays for the right to create ARKs or pearls or URNs in unlimited numbers. Probably should move along because first time I've tried to squeeze this 3-hour tutorial into 1 hour. So in the real world, or maybe I should say that in the real academic world, there's an ecosystem, and PIDs that publishers use play a key role. So tenure and promotion hang in the balance for some sectors, and DOIs are seen to be a kind of badge of academic legitimacy. So that's one big advantage to DOIs. Pearls are free, and they can be useful for if identifiers consist of semantically rich strings that don't need to resolve, or you have small numbers of them. URNs are useful if you're a national library, naming static assets, especially if you're from a country that subsidizes URNs or URN services, because you don't pay for URNs. They have a big advantage that they've been blessed by the IETF, so the internet standard, and that means there are software packages out there that validate them, no questions asked. So you can do some sleazy things with URNs that you can't get away with elsewhere. So handles are also popular in a lot of European projects where they're subsidized and they have a nice distributed network of preservation, the Donor Foundation with lots of replicated infrastructure. And DOIs have become associated with publication status, and so they're good if you can afford them. If you have only a couple dozen things to identify per year, by all means, go to Zenodo and get yourself DOIs. That's a lot easier than setting up infrastructure for another PID system. Sort of in summary, ARKs are similar to DOIs. They're both persistable identifiers for accessing content and metadata, and ARKs are found in many of the places that DOIs are found. In contrast, ARKs come with no fees, no limits on how many you can create, and no metadata requirements. From the beginning, ARKs were designed to be decentralized and to identify any kind of thing, digital, physical, or abstract. So here's a second use case or case study. This is for the Smithsonian Institution, whose NAN is 65665. Here you can see their NAN appearing in each one of their ARKs. It's a little small because they have long ARKs. One thing you can see in this is that there's a wide range of object types from, physical, like a violin, or biological specimens, paintings, photos, sculpture. The long opaque names, if you may be guessing and guessing correctly, that they're minting some of these with the UUID software. So this generates these unique strings that aren't by themselves resolvable, but you can stick them inside of URLs to make them resolvable. And they're found on every platform. So they're long, but they're unique and easy to generate. So we are, oh, you know what? I'll just mention something else. You notice that they contain hyphens. So the typical unprocessed UUID has hyphens in the middle, and ARKs specify that that hyphens have to be identity inert, meaning that if we see a hyphen, it's the same, the same identifier has to work with the hyphens removed. And that's because hyphens get introduced to identifiers, especially if they're long, and you don't know if the hyphen is meaningful or not. So we say they're all meaningless because of that problem. I think that problem was much more apparent in the last 15 years, or maybe the last 20 years, not so much these days, as typesetting and word processing has gotten more sophisticated about links. Any questions here? Andrea? Oh. All right. Well, how are ARKs free? And the reason is that, first of all, our costs are very, very low. So we're people who know me know how cheap I am, except when it comes to buying beer. But I do. We've kept our costs so low because we're just a redirecting service. We don't store anything. California Digital Library has graciously been supporting the infrastructure, and it's one Amazon instance, kind of a large Amazon instance, and they're supporting the technology refresh. So the result will be that the infrastructure will be even cheaper, and it'll be replicable. And we're asking people all over the world to like raise their hands and run a replica. And the replica will basically have a database of about 1,500 records. This is a tiny application. So we think that can continue on a volunteer basis. And the rest of the ARK Alliance is all volunteer right now. We do feel like we're going to have to grow up and form a proper nonprofit, just if only to pay for stickers and domain names, a couple domain names, and maybe. So we're paying, a small amount of money for a WordPress site, a low tier, but we're going to convert that to GitHub pages, so saving more money. So we keep working at that angle. Okay. So very briefly, a little more on the ARK anatomy. Ted.
So another question, many people that I talk to about identifiers think that the metadata associated with those identifiers is really a critical piece. And you talk a little bit about metadata associated with parts. Could you maybe elaborate, like what the option was none?
Yeah.
So in those discussions that I mentioned, identifiers without metadata, many people I think would, and maybe I'm one of these people, would think that identifiers without metadata are really not very useful.
Well, yeah, I'll try to repeat the question a bit. Talking more about ARK and ARK metadata and the extreme flexibility from no metadata to arbitrarily rich metadata. That is problematic for interoperability, for example. Problematic for, is it normal for this to not have something? Is it, So metadata is a very vexed issue. I know a lot about it, and I have as you know, and you know, in the discussions we've had, we've been very reluctant to commit heavily to a given metadata scheme because every single one of them is broken. You know, pardon me, but I think they're all broken, and I think standardized metadata is a kind of myth that we're getting closer to solving. But so the ARK approach is there's all sorts of legitimate use cases for the bare bones identifier that doesn't resolve at all. There's a resolver. There are things that resolve and don't have any metadata, and there are things that resolve and bring back minimal metadata. We think there is a kind of a ladder, and there is legitimacy at each rung, and it's for special classes and special cases. Also for different stages of life cycle development of an object. There are objects that are just beginning, they're in the planning stages. You name them before they exist. And that's okay. That should be okay. So that's weird to some people. How can that be? Well, we name our children before they are born. That's, you know, and we paint their room, you know, we get things ready for them. Then they exist, and it's sort of in this incubation phase where we're just getting to know this object, where it's experimental. We're going to start adding metadata, and over time we're going to figure out what we got wrong, and then, you know, anything that we care about, we tinker with. This is a really important factor, at least in my community. I guess we can, you know, the memory organizations, high value stuff is tinkered with all the time. So the bit streams are changing, the metadata is changing. So we need to permit that and support that. And I'll contend that, you know, the pursuit of the actual fulfillment of preservation involves lots of change and legitimate change. And I can get into that a little bit more. There's a paper we wrote about describing digital stickiness. It's like, what does it mean? Because you know, there's unchanging bit streams on one end, and there's like rapidly changing things on the other end, and there's preservation occurring in all of these cases. But I'm going to digress too much. But anyway, the metadata reflects that. So ARK has taken this like slightly middle row, which is like minimal metadata, which is kind of like Dublin kernel. So who, what, when. Give us that, if you please. Try your best to give us that. And if you've got missing values, we have 8 missing value codes to explain to us why that is. The ARK Alliance technical working group is going to be coming up with a recommendation, and we need your help and your input. So you're welcome to help us think that through and work it out. But a lot of it, like, depends, you know, there's a kind of a universal kernel, perhaps. That's a hypothesis. Then each domain has its sort of core, you know, maybe it's 7 elements. And then beyond that, you've got project level metadata, which is much more elaborate and richer. And then you've got mapping problems. And then you've got giant, just really painful ontology discussions. And all of that is like sort of separate from identifiers, but really is critical to the value. And I better stop myself because we'll run out of time. Okay, well, let's just plunge ahead. ARK anatomy revisited, a few more details. For example, the ARK reserves special characters. I mentioned the hyphen, which is identity inert, and then there's the slash and the period. And they have reserved meanings in the suffixes of the end of the ARK. They help the recipient make inferences about one resource being contained in another, or one resource being a variant of another. So this matches, it formalizes and matches what we already think of in the web world, right? You see maybe we're familiar with sort of folders, hierarchies, directory hierarchies. Well, this says that hierarchy is real, and you can actually, there's a containment relationship you can infer. Similarly with the endings. If two ARKs are the same, but they differ by .pdf or .html, it means they are variants of each other. So again, that if you don't want to make those relationships apparent, then don't use those characters. They might be present, but you might want to not disclose that for some reason. So if you did open n2t.net, I encourage you to go to your location bar and go to n2t.net and add ARK : and then hit enter. And then try that with DOI : or try it with ISBN : and each one of those should give you a little record. Nice monospace font record, which describes what N2T knows about that identifier scheme, or what have you, N2T? ARK : yeah. Pilot, what? And if you enter a NaN after the ARK : like 12148, you should see the record for the National Library of Medicine, or the several records that exist under for the California Digital Library. And you can enter any NaN that you are interested in. Not through this interface. The NaN registry is a simple text file, and so you can use grep. That's basically, you just look through it. We try to, I told you I was cheap, right? So, and if you go to the registry, you get to see some really nice ASCII art. I'm very proud of. So summarizing the NaN, the name assigning authority number, it's that 5-digit number. It's a resolution reference point. Those records reveal in them the address of the resolver where N2T will redirect incoming requests. It's that simple. It's a really, really simple technology. That NaN also isolates the assignment responsibility. So for things like autonomy, uniqueness, reuse, if you dare to use that. But it allows all this autonomous assignment to take place. Yeah. Yes, and that's happened. So the question is, can people migrate authority from one NaN to a new NaN? Yes, that can happen, and organizations change their names and keep the same NaN. Yeah. Some organizations have more than one NaN. So we used to think of it kind of like an organizational identifier, a little bit more like a ROR. But nowadays the thinking is they really identify like assignment streams, a stream of assignment from a particular place. So there are libraries. Library in the Netherlands has one vendor that's doing one assignment stream, and they needed their own NaN for technical reasons, stupid technical reasons you don't want to know about. But they have a separate NaN. So a lot of noise has been made about opacity, opaque identifiers and non-opaque identifiers, and there are advocates on one side or the other, and we take the firm middle ground. Opaque identifiers are painful for humans, but they're really good for, they age and travel well. So what we tend to do is think of, give opaque identifiers to logical objects, and then the extension, we encourage more meaningful extensions because these are like service access points. So if you have lots of identifiers, there are ways to generate them. One of them is just ordinary counters, opaque identifiers. There's this Noid software, UUIDs. It's a new kid on the block is ULIDs, which is a more compact form of UUID. So I encourage you to look at that. There's content digest, or even like legacy identifiers. There are organizations that have perfectly good identifiers from 25 years ago, and they can be transferred into ARKs. So Noid is nice because it's a nice opaque identifier. You can get a check digit, and it observes some rules about trying to avoid accidental semantics. So opaque identifiers are difficult for human beings. So sometimes you want a more friendly identifier for your backroom processes. So I mentioned ARK metadata being flexible, and a lot of this is tied to these, life cycle, early object life phases. And, throughout its life, there may be a big chain of preprints, there may be a big chain of postprints, but, stuff that we value and gets used, gets tinkered with, and a lot of value is added. And it's really hard to say that preservation is off the table just because it's morphing in different ways. A third case study from the French National Library, sort of zooming in from the global side. It starts the global world, there it identifies the ARK scheme, then the name assigning authority, finally the assigned name, nice and opaque. There's their resolver is Gallica, is their digitizing service, and then they add things on the end. So it's page 26, and there's a thumbnail, which they write in English, amazingly. So that's okay. So it's semantically encumbered, and in English. So one thing to note is, the assignment takes place at one phase, and actually there can be a kind of a post-assignment thing going on at the resolution. The resolver may actually offer different kinds of services, and that may be totally appropriate because as preservation services evolve, user expectations evolve. But, the thumbnail from 10 years ago is going to look pretty grainy, today. So the bit stream for the thumbnail will probably change. And that's a kind of a curatorial decision that's kind of post naming, right? So it's kind of irritating that this is not so clean, but you can have, these names as sort of and subnames assigned at different points. So there's a nice connection to the BNF study through these the IIIF image standard, very popular standard, and there's a natural parallelism between ARK suffixes and that standard. And this is about the need to address hierarchical subregions and variants within images. So here's an example of IIIF compliant URL and ARK. It requests the return from page 29, that's F29, of a specific rectangular region. This coordinates are given here, and a specific format, and the full version as opposed to the light version. So I think we're doing well for time. Yeah. By the way, I hope you're all inscribing your name in the notes.
So I think I'm still confused about who's doing the resolving. Like, is it the name? So N2T will resolve to the naming authority's domain, but then anything beyond that is on the name assigning authority.
Okay, so to start with, yeah, the ARK scheme is thoroughly decentralized. You set up your own resolver, you run your own resolver, you can publicize your identifiers as if they are rooted at your domain. So that's how the French National Library does that. Actually, they use ark.bnf.fr, but they send it to gallica.bnf.fr. In the meantime, if they chose to, they could have publicized their ARKs as n2t.net, because if you take that same ARK and you append it to n2t.net, it will look up in the record the ARK, the BNF ARK resolver, and it'll get there. Because of, yeah, it senses that it reads the NAM, says there's one place this goes, and it's all I know, and just sends responsibility is delegated.
So N2T.net is just redirect.
Yeah. In the original conception, N2T was holding a secondary copy of all the metadata. It did that for about 60 million identifiers from the Easy ID service and from the Internet Archive. The Internet Archive is now thoroughly autonomous, and Easy ID is on its way to pulling all of those, not using that part of N2T any longer. So the new N2T will be very, very lightweight, like, whisper light. So speaking of metadata, an ARK should get you to not only the thing it identifies, but also it should get you to a description of it and to a persistence statement. So some sort of record describing the commitment that the provider has to it. Originally, this was a single question mark that was a little hard to implement, so we're making it more explicit with this. You append a question mark info to the ARK. So here's in red, you see an ARK, and question mark info on the end returns more or less this record. It's slightly abridged. So you see sort of the kernel metadata coming back, and you also see bottom line is this sort of undefined, unavailable persistence statement, because this is like incompletely specified. And there's a lot of nuance to it. So the question mark info is an example of an ARK inflection, which is basically a grammatical device to change the meaning of a word by making small changes to it. So, in grammar, do, does, done, doing, all those words are not registered in the dictionary because they don't need to be, and that's helps you with maintenance. So it's rather than requiring people to invent a whole new identifier for the metadata, and so this helps you reduces the management load. So there's something similar. You've probably heard of content negotiation, which also you can use to get metadata for objects, and there's no conflict. ARKs can do content negotiation as well. In my opinion, it's a little harder, to do that because you need to mess with the HTTP headers, and you're also a little bit more limited because if you're asking content negotiation has this concept, sort of this prejudice about these formats are set aside for metadata. And if you have an object that's already expressed in that, you can't ask for metadata about them because they'll just return itself, because it says, oh, you're asking for metadata from the metadata object. So, but you can use either one. So the response format is not fixed, it's evolving, but it should be human and machine readable. The version you saw before was close to YAML. It's an older version called Anvil. So persistence is not on or off. It's nuanced. This is a really important question. So, people ask, well, geez, here's this big file that's rapidly changing every 6 seconds. It's an Earth sensor, and it grows every 6 seconds. And some people say, well, this is impossible to characterize as persistent because it's always changing. This particular kind of change is really special. It's always growing at the end. So previously written data is quite stable. So we invented a term for that in a paper we wrote about, well, that's pretty stable in a way, except for this sort of growth factor. So it's much more tractable than something that's unpredictably changing all over the place inside previously written data. So that's actually very close to what a journal comes out, regular issues come out, sort of effectively appended to the journal. But then there are things like, have you ever seen, Linux distributions? If you ever install software and there's something that says, well, here's the long-term stable version from 3 years ago, and you look at the modification data and it was last week, and you ask yourself, how the heck can that be persistent? Where's the preservation? Why did that happen? And then you think to yourself, well, in the real world, there are things like high, critical security patches that go through. There is malware detected. Harm could be caused if they don't correct something. So preservation is occurring to a certain kind of experience, but it's not exactly identical. So you have to balance. The balance is between, the service you're providing and preservation. So this happens with PubMed abstracts, for example. The biomedical literature, the PubMed is preserving all of this biomedical literature and abstracts, but they will reserve the right to change like author names if they get misspelled, because authors get upset. And especially they'll change something like a dosage. Doctors looking up in their office, like the dosage of that is wrong and it's in the abstract, and that may not get past the abstract. So they think saving lives is more important than preservation. And we could argue with them, and maybe, and there probably should be some copy of the original just to show, what was done in some kind of forensic case. So this is the real world. Is people expect valuable things to be kept up in a sense. The genealogists had an example. They said, well, they're pressured by their users, active family researchers who want to know, get early results from the latest scans of historical documents and photographs. And so here's a cabin that shows up in last year, and it was labeled with, oh, this family lives here. But a year later, scholarship reveals that 2 families lived there. So they have an ARK record which splits into 2. And they justify this by saying, well, we're trying to preserve the past. It's not so important to preserve the digital artifacts exactly as they were. Or if we do, there'll be tombstones and redirections. So they reserve the right to do that because their loyalty is to the past, and scholarship changes and science changes. So valuable objects are often complex and they're volatile, and humans, we can't stop ourselves from tinkering with them. So we wrote this paper, and it's in green on my slides. There was a whole bunch of proposed terminology, which is not fixed. So I kind of qualify this. I think it's an interesting paper. Love your help and advice on this. We're trying to characterize how to set expectations about what might change at the next visit and what we do as an organization, because very, 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 very few of us have frozen bit streams, or we have them, but attention moves on to the newer bit streams. Even if the old bit stream's available, it's often not interesting anymore. So we'd love your help with that. Object types. a lot of questions people ask, well, how do I model my objects? Do I have physical, in a lot of objects, they start physical, they have some physical presence, and whether it's the Eiffel Tower that's in that photograph, are you preserving the photograph? Are you preserving the concept of the Eiffel Tower? So there's philosophy in here. What's digital and what's physical? I could argue convincingly, I think that every digital object actually has a physical presence, whether it's voltage or some optical bump that's being read. But losing that distinction is not very helpful. But anyway, you can tie yourself in knots thinking about this stuff. But I could also argue that everything is conceptual, right? And the philosophy backs that up pretty well. But what we tend to do in the ARK world is think of logical objects that are kind of like, there's this concept of an object, you identify that opaquely, and you have a high commitment to that object. And then over time, you have a varying different ways of serving that and fulfilling your preservation function. So you have some leeway in there to, like, you may have a lower commitment to the thumbnail of the object than the object itself. And that's totally fine. So that's why you might have less opaque extensions at the end of the suffixes, but more opaque and high commitment to the logical object. There are a bunch of tools. It's hard to go into them in detail, but there are minters and resolvers software. There's this original Noid software, which is kind of ancient and really you probably don't want to use it. There's a Dockerized version of that called ARK Noid, and there's also the Internet Archive has their own software called ARKlet, which they're running. If you just want to mint opaque strings, you've got some tools there. There are also some plugins, like if you're running in a small journal, you can take OJS, and there's a plugin that works for ARKs quite nicely. There are also some in-house library systems. The University of Toronto at Scarborough did a nice piece on that. And if you're implementing ARKs, you should consider the suffix pass-through function, which is quite nice. N2T supports this, and it works quite well for stored identifiers, which that won't be the case much longer. But basically, it starts with the notion that every object is the root of its own namespace. Right? You might have a million objects in your collection, but you could have a million sub-objects hanging off of every object. So what if it's a database? You got an ARK for a database, and it's got a million cells, and you want every one of them to be addressable. Well, how might you do that? First of all, it's nice that you don't have to pay for the million sub-objects. It's also really nice if you don't have to manage them all, right? Manage separate registrations for each one of them. So this suffix pass-through concept is based on the Perl partial redirect, actually. It's an old technology. But the idea is that basically you do what the Smithsonian does. The Smithsonian has millions of identifiers, but they have about a couple hundred ARKs registered, and they're just these stubs that are recognized as like the beginning of my ARK, and the rest is, oh, we send it off to that part of the Smithsonian, and they handle the rest of it. So this is a visualization from my colleague Dave Iglesias. It allows us to visit the South Pacific island of Moorea in French Polynesia. Each of the colored points represents a physical sample, and the towers indicate that many samples were collected at the same geographical location. In the iSamples project, each sample point has an ARK identifier, which is displayed when mousing over the sample points. Clicking on a sample point will bring up a summary metadata record for the sample, and that allows you to link back to the original collection. Following that link to the Smithsonian, you can find out more details about the specimen with cross-references to analyses and publications and other material. The interlinking is facilitated by millions of ARKs, and the number of participating collections is expected to expand significantly as the project continues. It's all part of the NSF iSamples project, which Joan and Andrea know well. And it assigns identifiers to biological specimens, rocks, and archaeological artifacts. So that is our last case study. And this here is a form where you can go right now. If you call in the next 5 minutes, you can get your own NAN. Well, you fill out a form, this Google form, and the NAN curator working group gets it and looks at it for plausibility and spam, and well, you should get a NAN in 48 hours for your institution. Yeah, actually nan_registry.txt is the end of it. It's probably at n2t.net/e anyway. It's probably that's a little bit of a no-no. We want you to be an organization. We want you to have a persistence, a promise, some organizational backup. There are some projects that just get started, just getting going, and there's like, say, we want an end because we're getting ready, and we'll come back to you when we're with our resolver, when we build our resolver in a year. So that can happen, but we want you to be more than if we suspect that you're just a person and your cat or something.
How like if my university has a NAN, but my lab within the university wants a different NAN.
You can do that. That's totally plausible. And it happens. We used to be stingy about NANs, but then we started to EasyID started doing, new DOI prefixes for individual journals. So one publisher has 5 journals, each one got a prefix. So we said, well, similarly, we can give out NANs at that kind of rate.
So
So persistence, all your philosophy aside, and the complexities of persistence, but much of it relies on an institutional commitment.
Yeah.
But you're not making any sort of assessment of the institutional commitment. You're just like, okay, this seems.
We make a
easy.
tiny, we make a stab at it, similar to what DataSite does and what we did in EasyID. We'd ask people to, check a box. It's like it's a very crude assessment. But
Right.
it's
So NANs die.
NANs die, prefixes die,
Yeah.
DOI prefixes die. They all, yeah.
Yeah. Okay. And then when a NAN dies, since it could be potentially millions of ARKs that die with it.
Well, how
Do
do you
you
know
worry
when
about
it's
that?
died? How do you
Yeah,
know? We
Well,
don't have
that's
them.
my
Yeah.
question.
We don't have them monitored mostly. We've never had any issues that had to be chased after. Like we have had 2 cases where we had to chase after somebody, but a lot of cases we wouldn't know if we know there are NANs that have been given out that aren't being used. We know that, but we don't know how many because it's not centralized. So we're close to time, but Morgan, you can tell me when we need to break.
So how do you link people to the organization? So I looked up, I'm with USGS, and turns out we have a NAN. I have no idea who's responsible for creating that. Like if I came to you and said, I'm going to take this over,
Yeah,
could I?
you
Or
should submit a request, and what would happen is we have access to the contact information because that's suppressed from the public registry.
okay.
And we could ask you to, we have so-and-so on record. We haven't heard from them in a while. Would you like to talk to them, or can you take it? You want to take it over? Yeah.
Okay, awesome.
Microphone.
So when you talk about N2T and you say that it resolves 900 different compact identifiers, does that mean that there are 900 different NANs?
No, they're not NANs at all. They're before the NAN begins, there's an ARK colon where the
Yeah,
ARK
okay.
colon would be, there could DOI colon, there could be ISBN. There are 900 different identifier schemes. A lot of them are biomedical databases that
Yes.
have been entered by the identifiers.org, and we had a formal agreement with them to share prefixes with the biomedical community.
So does that mean that I can use N2T to resolve ISBNs
Yeah, I'm not, what I don't know is the
or
quality of the
ISSNs?
ISSNs. I don't know the quality or the official status of those resolvers. That's the best we know. And
'Cause
that
that would be really cool.
it would be, I mean, it's really nice because you don't have to
seen their
remember,
website.
you don't have to remember all the 900 different locations of these resolvers for these,
Right.
some of them are very highly used data
Cool.
sets.
I will try that one.
Probably on there if there's.
Okay, so I think that's actually the end. So thank you.